Hey you guys, sorry I'm not there with y'all today, but I'll still be teaching from afar. So far we have looked at quadrilaterals, angle sums, and then last class we looked at parallelograms and how to prove things are parallelograms. So today we're going to be moving to our second quadrilateral, which are rectangles. And by definition, a rectangle is a parallelogram with four right angles. Now remember, parallelograms have opposite sides that are congruent, opposite sides that are parallel, opposite angles that are congruent, and opposite angles that are supplementary. So all of those definitions still apply to a rectangle, except now our new part is that all four angles have to be right angles, which leads us to our first characteristic, where all four angles are right. Our second, where opposite sides and angles, opposite sides are parallel and congruent. Opposite angles are congruent. Consecutive angles are supplementary. Diagonals bisect each other. And then the diagonals are congruent. Now, really, all six of these are not all new to us. The only new ones that now apply to a rectangle that make it a specific rectangle instead of a parallelogram are going to be 1 and 6. Because 2 through 5 still apply to a parallelogram. So when we go down and we look at example 1, we want to use these properties of rectangles. They tell us that if segment TS, which is right here, if TS is 120 meters, then we want to find PR. Well, I know that if TS right there is 120, then TQ is also 120, which means that SQ is also equal to 120. And because these are rectangles, our diagonals are congruent, so SQ has to be congruent to PR. So we know that PR is also is 240 actually. Because if ST and then TQ are 120, that makes our SQ 240. We have to double it. Our second one we're going to look at 1B is they tell us that the measure of angle PRS is equal to 64 degrees. So right here, 64 degrees. They want us to find the measure of angle S right here. We know that these diagonals are congruent and they also bisect each other. So PT must be congruent to TR, and then QT must also be congruent to TS. Well, that makes this triangle right here an isosceles triangle. And we know that the base angles, which are the angles on the bottom across from the two congruent sides, we know that those are congruent in isosceles triangles. So the measure of angle S will also equal 64 degrees. When we look at example 2, now we're going to use the same properties but use some algebra with it. We are given that JP is 3y minus 5 and MK is 5y plus 1. So we're actually going to rename this triangle JMPK, so our letters match up. And they tell us that the entire diagonal of JP is 3y minus 5. And then the entire diagonal of MK is 5y plus 1. Because these are rectangles, we know our diagonals are congruent, so we can take those two expressions and set them equal to each other. When we begin to solve our equation, we get 2y is equal to 6, which gives us that y is equal to 3. Now, had they asked us to find the actual diagonal length instead, all we would do is substitute that value for y in. So now we come to theorem 6.14, diagonals of a rectangle. If the diagonals of a parallelogram are congruent, then the parallelogram is a rectangle. And you know that based on the definitions and the characteristics given to us in the first examples. So we're now going to take that and apply it to actually prove rectangular relationships. So set design. Refer to the beginning of the lesson and what we discussed. Leonardo measured the sides of his figure and confirms that they have the desired measures as shown. Using a carpenter's square, he also confirms that the measure of the bottom left corner is a right angle. Can he conclude that the figure is a rectangle? Explain. So since our opposite sides are congruent, we know it's a parallelogram. So that's the first thing we know. So yes, because opposite sides are congruent, then it is by definition a parallelogram. But taking us back to our 6.3 notes, actually probably our 6.2 notes, if one right angle in a parallelogram, if one of the angles is a right angle, then all four are. So because this angle right here is a right angle, we know that all four of them are also right. So now we know that opposite sides are congruent and all four angles are right. So that is enough to define this as a rectangle. Our last example for this notes page is going to be taking rectangles and then looking at coordinate geometry. So we have the quadrilateral JKLM with vertices at -10, 2, -8, -6, 5, -3, and 2, 5. We want to determine whether this is a rectangle using our slope formula. Now, because they've told us to use the slope formula, we are going to need to determine the slopes for each side of that rectangle and make sure that they are perpendicular to each other. So the first thing that we need to do is plot all 4 points. So go ahead and take a moment and do that. Right, so now that you've plotted all your points, go ahead and connect them. Make sure you label your points and connect them. We're going to pretend like that looks nice. So in order for this to be a rectangle, the slope of JM must be perpendicular to the slope of ML. The slope of ML must be perpendicular to the slope of KL, and the slope of LK must be perpendicular to the slope of JK. So using our slope formula, which remember is the change in y over the change in x, we need to identify the slopes for JM, ML, KL, and JK. So I'm going to zoom in very quickly so we can see this better. And between JM, I'm increasing by 3. for the vertical axis. And then for the horizontal axes, I'm increasing by 12. So that slope would be 3 over 12, which would equal 1/4. Now for ML, I'm still increasing by 3, but now I'm decreasing that y by 8. So the slope of ML is going to be -8 over 3, which I can already see that these are not perpendicular slopes. So this is not going to be a rectangle. So we can zoom back out and we can justify our answer saying not a rectangle because our slopes are not perpendicular. Okay, now we're going to move on to the next part, which is number 9. And again, we have these 4 coordinate points that create our rectangle, and now we want to prove it using the distance formula. Well, we know that if opposite sides are congruent, that makes it a parallelogram, but we want to prove that it's a rectangle. So we need to actually be looking at the diagonals and seeing if those two are congruent. So we're going to plot all 4 of our points. So we have A at 4, 3, B at 4, -2, C at -4, -2, and then D at -4, 3. Now I know you guys are going to want to say, look, we can prove that they're perpendicular, we can prove that they're congruent, and you're right, we can, but they're asking us to prove it using that distance formula. So I need to find the distance of DB, which is that first diagonal, and then the distance of AC, which is our second diagonal. So looking at points D and B, when I look specifically just at that x coordinate, I know that the distance on a number line between 4 and -4 is 8. So that is 8 squared plus, now I'm looking at the other distance between the y's, which is -2 and 3, which makes 5 squared. So we have the square root of 64 plus 25, which gives us the square root of 89. So now we just need to look at AC. So looking at point A and point C, the distance between the x coordinates is 8, so 8 squared, and the distance between the y coordinates is 5. So we can already see right here that they are going to be congruent, but when we work it out, we still get 64 plus 25 and the square root of 89. So because these are equal and congruent, we have proven that this is a rectangle. All right, you guys, I hope this all made sense. If at any point you need to pause and rewind, please feel free to.